But dang it, guys, you guys got me addicted to USACO again. Bruh. Dude, I was planning on not doing USACO at all after the last contest of 11th grade, but no, you guys just have to make me addicted again. Dude, the adrenaline you get from seeing all the green boxes is crazy. Hello everybody, I'm Karara, and today we're going to be doing problem 1 from the bronze of the US Open that just happened a couple weeks ago. And the reason for that is because I had so much fun making the video before. Like, actually, honestly, it was kind of fun. Not gonna lie. So currently what I'm planning to do is I'm going to do this problem on bronze, then I'm probably going to do gold 3, and then I'm going to do the rest of silver, and then if you guys have any more suggestions, then let me know. But anyways, let us jump into the epic problem solving. Alrighty, a terrible new disease, COVID-19. Yes, the COVID-19 references once again. Youth go back at it again. Very nice. Farmer John is trying to take as many precautions as possible to protect his herd from infection. Farmer John barn is a long, narrow building containing n stalls in a row. N is less than or equal to 10 to the 5. Some of these stalls are currently occupied by cows, and some are vacant. Having read about the importance of social distancing, of course, Farmer John wants to maximize D, where D is the distance between the closest two occupied stalls. For example, if stalls 3 and 8 are closed, blah blah blah. Okay, two new cows recently joined, and he needs to decide which formerly unoccupied stalls they should be assigned. Okay, please determine how he can place his two new cows so that the resulting D value is still as large as possible. Farmer John cannot move any of his existing cows, he can only assign stalls to new ones. Okay, so the first line of input contains n, okay. The next line contains string of length n, zeros and ones, okay. Zeros indicate empty stalls, ones indicate occupied stalls, and it has at least 2 zeros. Okay, so please print the largest value of D that Farmer John can achieve after adding his 2 new cows in an optimal fashion. So basically n is less than 10 to the 5, right? So we know that our algorithm has to be n log n, but I think in this case it's probably going to be n time, because there's not really anything to sort. Okay, right off the bat, like, I think the idea is that you have to take the current biggest gap and put in the new cow so that it splits that gap. Because if you, maximize D, where D is the distance between the two closest occupied stalls. Okay, yeah. Because if you put a cow in a smaller gap, it's guaranteed to make the gap even smaller. So that will make your D even smaller, which is not good. So you want to split the gaps that are even bigger. Okay. So like just looking at this one, right? This gap is massive compared to the other gaps. Actually, wait, this is the biggest gap over here. So we want to split this gap over here. So we'll take out one of these guys and put in a 1. And of the remaining ones, this gap over here is the biggest. So we want to put a 1 in there. And then right now we can see that our smallest gap is right here. And that just gives you your 2, there's 2 separating it, so our answer would be 2. Now the only problem here, I think, is like the ends, right? Like, what do you do about the end? Because let's say you put a 0 here and another 0 here, then instead of making this guy into a 0, it's better actually to make this into a, actually it doesn't even matter at this point. Wait, let me do an example, let's see. So let's look at this example, right? Like in this case, if we take the biggest gap, let's put a 1 in here, and then the next biggest gap would be over here. So then we would put 1 over here, and now our smallest thing, unfortunately, is only 2. But we could have done better if instead of making this a 1, we make this end a 1. So the ends kind of complicate this a little bit. So the way I was thinking to do the ends is you just add another 0, 0, and then a 1 here. So that means if you added it to the gap here, then it would be the same as splitting that gap. Yeah, okay, so that basically works. If we extend the ends just by, like, basically we take an end that looks like this, and then we basically just reflect this part over, so 0, 0, 1, so that if we put a 1 at the end, the gap is like the same. Because we get a gap of 3 on this side and a gap of 3 on the other side. Or, do we even need to worry about that? We could just, like, do a case that's separate. Yeah, why don't we just do a separate case? We'll just, like, find the 2 biggest gaps to put in the cow, and then we can find the ends and see whether it works better to do the ends. Oh, another case to consider is that if the biggest gap is like really big, you could put 2 cows into it and it would still be better. Is there a smart way to do this? Because that's just like too many cases for me to handle. Well, I mean, okay, let us write out the case, right? The first case is you put 1 in each of the 2 biggest gaps. And then we can do our extension thing just to make sure that we don't have to do an extra case. We could just turn the ends into gaps. Oh wait, no, we could just keep track of the distance after putting 1 thing into it, right? So I think the best way to do this actually is like keep an array of space without adding anything into it, space without adding in, and then space after adding 1, and then space after adding 2 cows in between it, like the max space you could have between it. And basically you want to take the maximum of either this guy and compare it to the max of putting 1 in each of the top 2 guys here. And then this one over here is just going to be like beforehand what our D is. And I guess we could just sort it at the very end. So for the first one, we only care about the smallest one because that will tell us what our D is before. Then for the last one, we only care about which like the biggest one is, because we want to make sure that they're as far apart as possible. And then space after adding 1, we only care about the top 2. So we don't even need a sort. We could just go through it one time and keep track of the top 2. So let us code. What is this boy called? It is called social distancing 1. Wow. Stop this 1. Should we do this in C++? I think we're going to actually do this in Java. Okay, let's just do it in Java because that's going to be fun. Well, honestly, this problem is simple enough that it's not going to be too different between any of the languages, so let's just do it here. So stop this 1. Yeah, I'm coded in Java for eons. This is going to be fun. So the first thing we got to do is get our in and out stuff. So scanner, so new scanner, and then we're going to do new file, and then we're going to do sockdis.in, sockdis1. And then we got to import Java util star, and then we also got to import java.io. Okay, and basically we can also get our buffer writer. I forgot how much I don't like I don't like Java. God dang it, so much work. Alright, and then what we're going to do is we're going to do int n is equal to good on next int, and then what else do we need? We got to read in all the rest of the string. Okay, so we'll do string s equals good on next line, or that will not work. Let's just do, yeah, next. And now we'll go through it and we'll keep track of when our gap starts and when our gap finishes. So at every 1, we'll say that our gap finished. So we'll go for int I is equal to 0, I less than n, I plus plus, and then now we got to keep track of int card_d, which is going to be your card D before we add anything in, and we'll set it to some obscure number, let us say like that. And then we also got to keep track of our top 1 and our top 2. And then we got to keep track of our top add 2. So the reason why I made cardi like a really big number is because we're going to be taking the minimum of the incoming thing. And then for all the rest of them, I made them 0 because we want to take the maximum gaps, the biggest gaps we want. And then top 1 and 2 are for if we add 1 into the gap, how much space is left, and top add 2 is if we add 2 into the space. And then we need an int for the gap start. Int gap start is equal to 0. Actually, it's 0, and then if we put a 0, 1, then it should give us, actually no, that's fine. Okay, so let us say int car is equal to s.getCar@, or actually, could we just do, or we could just make this a bool. So boolean car, and then we could say that this is equal to s.car@, I equal to, what car do we want it to be? If it's 0, then we want it to be false. So if it's 1, we want it to be true. Okay, so if car, as in if we're at a 1 currently, then we have to take the current gap is going to be from 0 to now. So if it's a 1, what do we want to do? So if gap start is equal to 0, this is like the first gap, right? This is like the first 0 to the first count. So if there's no zeros, then gap start is still going to be 0. But anyway, so this is a case where we're starting from the beginning, but we haven't encountered a 1 yet. In this case, we don't want to change current D because we haven't encountered any cows yet. So this is the first cow, so we haven't had any gaps yet. However, this could be our top 1 because if it's 0, 0, 0, 1, we could put a 1 at the very left, and it will be that, whatever that gap is. So if gap start is greater than top 1, and in this case, top 1, top 2, and top add 2 are not going to be set at all. So we just got to set top 1 to whatever this gap is going to be, and top add 2 to whatever it is. So let us look at how this would be. So if we add 0, 1, that means our gap start would be 0, and our I would be 1, and the D after we insert 1 here will be 1. So basically our top 1 is just going to be I minus the gap start, okay, which is just 0, so it'll be I. However, if we want to add 2, that makes it more complicated because let's say that we have 1, 0, 0, 1, then it would be 1 if we added 2. If we made it 0, 0, 0, 1, then it would still be 1, and I would be 3. if we had 0, 0, 0, 0, 1, we could add a 1 here, we could add a 1 here, so the D would be 2 in fact. So basically you can make it top add 2 is equal to I over 2 plus 1. So if I is equal to 1, would that work? Or no, we had to do, does that work? Let's see. Wait, it should give 1. Oh wait, so just I over 2. Okay, that makes sense. Because in this case, we would get that it's 1 because you could put 1, 1. In this case, you get 1 again because D is still here. However, once you get to 4, it'll be 1, 1, 0, so you can get 2. Okay, that makes sense. However, if it's not D equal to 0, then we have to do that like starting at some arbitrary point. And we could use the same logic here, except slightly modified. So basically, we want to find if we have a gap, like 1, 0, 0, 0, 1. If we add 1, what is the D after that? So if we add 1 here, then the D is going to be 2. And originally, we had, like, let's say this is I, and then this would be I plus 1, I plus 2, I plus 3, I plus 4. So that means the difference would be 4, and the D would be 2. However, if we made this 1 less, then our D would only be 1. So that makes sense. Okay, wait, the gap start is going to give us this 0 over here, ideally. Or no, we could just make it the previous one. So we'll do gap start is equal to I. And then we could do top 1 is equal to I minus gap start over 2. Now obviously we want to add 2 to this. Then, in this case, like, let's see. So the distance is 4, and then you divide by 3. Let's say you had 6 difference, because you had to divide it into 3 chunks. So let us say you had 1, 0, 0, 0, 0, 0, 1. So in this case, our difference would be 6, and we could have a distance of 2 between each one. So we just divide by 3 in order to get our top add 2. However, this time we actually had to do max, because we might have found better gaps before. So max top 1 comma this. And then same thing for our top add 2, and this time we had to divide by 3. Okay. And then we also have to keep track of our current D. And then our current D is just going to be the end of the gap to the beginning of the gap, which is I minus gap start. And we have to take the min. And if it's a 0, we just don't do anything, because zeros don't even matter. So that should be fine. Oh yeah, and then here we have to do gap start is equal to I. Okay, and then at the very end, well, let us just check whether this works and give us the right top 1, top 2, and top add 2. Okay. Alrighty, let's test it out. Let's make our in file, and we will put, what's the thing? Okay, let's run this boy. Whoops. Did I forget how to do riders? Let's see. Oh bro, you gotta report exceptions. God dang it. So throw the IO exception is the easiest way to do it. So we get 3 for our car D. So that means right now our smallest gap is 3. Right here, that's the smallest gap. Okay, good. Our max, oh wait, whoops, I didn't do any of the top 2 stuff. It should not, okay. We had to do our logic here. So, to keep track of the top 2, we basically check first if it's the biggest one. If it's the biggest one, we put it into the big one, and then shift whatever than the current biggest one down to the second place. If it was smaller than the first place, but bigger than the second place, then we kick out the second place. If it's smaller than both of them, we don't do anything. So first we gotta check if it's bigger than the first place. So we'll first store our I minus gap start, and then we'll do our logic. So if j is greater than top 1, then we make top 1 equal j. Else, if j is greater than top 2, then we set top 2 to j, and that should be it. Okay, so it's basically saying that sounds wrong. Okay, yeah, we should set gap start to -1 originally, so it's not too confusing. And then we should subtract 1. No, that should be fine. Okay. Because the problem what it was doing is if you have a 1 at the very beginning, the gap start will still be 0, so that's not right. So we had to make it -1. Okay, this seems more right. So 3 makes sense. Then the 2, we have a 2 over here if we put it in here, and then if we put it in here, we also have 2. So that's right. And then 1. So the biggest gap is here, and if we put 2 in here. Wait, we put 2 in there? Yeah, if we put 2 in there, there's no way to make d equals 2, so that's why the biggest thing we get to have if we enter 2 in the same gap is going to be 1. Okay, good. So now our thing is working. So at the very end, we want to take either we put 1 in each of the top 2 ones, or we put 2 in the same gap. So we'll take the math.min of them. So we'll take math.min of top, well, we first have to take math.min of top 1 comma top 2, and then with the min of top add 2, and then we had to take a min again with car D, because the car D is smaller than what we already put in, the new stuff, then the current D doesn't change at all, right? Because like, for example, let us say we have a really big gap here, right? And we have 1, 1 right next to each other. Even if we put our new ones in here, our gap is still going to be 1. Even though the new gaps that we created are distance 2, our smallest distance is still 1 because that's what it was originally. So we'll have to min it with the original D. Dude, watch it be that you could just literally write math.min and then put all the commas, but I have no idea, so I just put it that way. But let's see. Whoops. BW.close. Oh, what? Why did it put it in a box? What the heck? Oh, do I have to like make it into a string? Let's do that. But maybe I thought it was a care. Oh, that would make a lot more sense. Oh, wait, I'm trolling. So, we want to take the min of the 2 distance that were created, but then we want to take the max because we want to have a bigger distance. So we take the max over here, and that will give us the biggest gap that we can maintain, and then we have to take the min with the current smallest gap. Yes, okay. Just to explain that again, like top 1 and top 2 are happening simultaneously, right? So in order to find what the min distance is, we gotta take the min of the 2. However, we could instead, they're not happening simultaneously, add 2 into the same gap. So we want to take the better of the 2, which means it has a bigger gap. So that's why we do max. But then over here, current D is happening simultaneously to the insertion. It's already there. So that's why we gotta take the min there. So this should work. Let us try it out. Alright, we're gonna do Java. Dang, I haven't submitted in Java for like eons, bro. Alright, please work, I beg, dude. This is my first time submitting Java. You gotta give it to me. Please, I beg. Well played. What the heck? Softest 1, right? Oh, why did I put 2? What the heck? Bro, I'm trolling. God dang. Okay. We're not gonna troll anymore. Dude, that's such a well played move, dude. My first submission as Java gotta be wrong. God dang it. Okay, let's work. I beg. Come on, man. Come on. What? No. Bro, am I incapable of doing bronze? What the heck? Oh, I didn't do the end. Like, why would it be added to the end? Oh, bruh. I did the front. Like, if there's a 0001 at the front, I did that, but I didn't do it if there's 1000. Dude, I literally thought about, bruh. Okay, whatever. Okay, let's fix it. So then at the very end, we just have to copy and paste this logic, except do it for the, actually this is different, it's just different logic, but our J is going to be different and everything, but let's just do that. So we won't divide by 2 because we could put it at the very end. So it'll be n minus gap start in fact, but minus 1 because it's n minus 1 to gap start, okay? And then over here, we could do n minus gap start minus 1, and then divide by 2. So long as we added like a bunch of zeros over here. So this means we could put a 1 here, and we could put a 1 there, and it should be superior. So let's test it. The answer should be 3 now. Whoops, whoops, supposed to be n, right? Oh wait, it doesn't even matter, we don't need this anymore. This should be, take this out, we don't need this, okay. Still not working, okay, let's see. So, should be n minus gap start minus 1. So if we have n is equal to 14, oh wait, this is not, okay. We had to extend it. So how many did we add? It was like here, we added 5 things. So it should be 19 now. Okay, much better. Okay, this should work. Hey, let's go. Is this working? No, it didn't work. God dang it. What? This is so sad. What the heck? God dang it. Oh, oops. Bro, I don't even move my top 2 down. Like, okay, so if you kick out the top 1, you have to move it to the top 2. Bruh. I literally do not know how to code. God dang it. God dang it, dude. I literally explained it right, but didn't code it right. This is so sad. Okay, I promise I know how to code. Don't unsubscribe, please. Oh my, that's just sad, dude. And it's still not working. God dang it. Now what's happening? Is there something that we're not thinking? Bruh. Oh my god, this is so bad. What am I doing? Bruh, there's just one case that I'm missing. Oh, okay, well, let's think of our... So, I have thought of all the cases, right? Either you put 2 into the same thing, or you put 1 in 2 separate gaps. Is it a case where the last 2 are 1, or the last 1 is a 1? Then our gap start is going to be n minus 1. So this would be 0, and that's fine. Oh, well, I guess this has to be, it'll start at 1. Maybe, okay, I think that's fine. Let's make this 1. Because you can't have any gaps smaller than 1. So 0 is just wrong. Okay, this should be better, I think. Okay, I think I need to practice some more wrong problems. You know, demote me from plaid. Okay. Oh, right, I submitted as C++, well played. Oh my god. Took me 5 submissions to do a bronze problem. Yeah, I deserve a demotion, god dang it. Did I do it again? Bruh. Oh no. Oh, my brain is dying. That's not the problem? What is the problem? God dang it. Is this big enough? Yeah, that's way more than 10 to the 5, so that's not the problem. Oh wait, if it's equal, it also... Oh my god. Oh, holy. This is why you think things out carefully, okay? Because, like, it's okay if your top 1 and top 2 are equal. Like, if your J is greater than or equal to top 1, it's okay if you kick this down. So let's say, okay, let's say that your top 2 plays were 5 and 4, right? And you get another 5. Then what you want to do is you want to kick the top 1 down to the top 2, and now you have 5, 5. That's what it should do. But this is not, oh my god, dude. How do I make the stupidest mistakes ever? Well, who cares? Found it. We're chilling, okay? Dude, I'm getting tilted so hard. God dang it. Okay, this should work. This better work. Please work, I beg. Alright, this time we're doing Java. Okay, we're doing Java. And then we go here. Alright, this better work. God dang it, dude. God dang it. What? No, that's not the problem. What am I doing? Bros in Cephalon. Fine, let's try some stupid inputs. Okay, let's try 19 ones. Maybe there's only zeros? Oh wait, maybe it's only zeros. Oh my god. Ah, USACO, why you gotta troll me like this? God dang. This is a problem, because then you go put it on opposite. Oh no. That's so big brain, god dang it, dude. God dang it. The answer should be no. Ah, okay. So we need to do 2 cases here. That took me so long to get. Holy. Okay, if gap start equal -1. Or no, yeah. So this is if gap start is not equal to -1. So if it's equal to -1, that means we only have zeros, in which case our top add 2 is just going to be n-1. So we'll do top add 2 equal max.max top add 2 comma n-1. Else we'll put in the new thing. And we don't even have to change top add 1 because that just doesn't make sense, right? Because, like, if there's only zeros, you have to put both of them in. Oh, there won't be a gap. So this should work. Okay. Dude, I hate this problem so much now. Okay. Holy, it took me a while to find. Okay, theoretically, you're supposed to design algorithms that don't have this potential to get trolled like that. How did I get trolled like that? I don't know. Alright, finally! Okay. That makes so much more sense. Okay, I see. So, is there a way to make this, like, less prone to that kind of thing so that it would work no matter what? Maybe if we do my strategy where you just, like, add in the extra gaps. I don't know, that's kind of equally nasty. So I guess this is just one way to do it. I just need to be more careful about what my algorithm is, and then I guess we would figure it out. Okay. Alright, I hope that was helpful. I kind of trolled on that one, not gonna lie, but basically, the solution was not super complicated. It's just the implementation got kind of yucky for my particular algorithm. I'm not sure exactly what USACO does, but yeah. Thank you guys for watching. If you guys want more USACO walkthroughs, just let me know. Give me suggestions on which problems you guys want to see from the open. Let's just quickly check what they did for their solution. Let us see. Oh, they literally did the same thing, kinda. Oh, yucky. Oh, dude. Yucky. They did like 5 possibilities. Okay, theirs is equally as nasty, so I think we're good. Alrighty, as always, if you enjoyed the video, leave a like and subscribe for more. Thank you guys for watching so much, and see you guys next time.